Hi guys, today we're going to take a look at lesson 84, algebraic terms. And so a couple of keywords you'll need to know is term, which is part of an algebraic expression or equation. And we'll see that show up here in just a second. And then polynomials are algebraic expressions that contain 1, 2, 3, or more terms. Okay, so here's the difference. Okay, so some polynomials. A monomial, mono meaning one, has one term and it could look like negative 2x, okay? A binomial has two terms and it might look like 9 squared minus 4b squared. So you'll notice that here we have a term and then there's another one which is signified by a symbol in front of it. So those are two separate terms, okay? And then a trinomial has three terms. So if I were to blank these out, I have 3x squared, comes another one, minus x minus 4. Okay, so each of those are their own terms. So terms are separated from one another in an expression by either the plus or the minus. So we see like this one had the two minus symbols, so that separated the terms. And they are not considered symbols of inclusion, okay, so it doesn't dictate order of operations. And then to help see the individual terms, you could separate the binomial and trinomial examples with slashes, and we've done this before. So for example, if I took this one right here and then the second one, I could actually find where the term is with its symbol and then divide it from the one before it. Okay, so I can divide them so they look separate, and this is purely to help you keep your thoughts organized, okay? So every term contains a positive or negative number, okay, and may contain one or more variables or letters. And sometimes the number is understood, which means like a squared, it's understood that it is 1a squared. It's one of them, okay? There's only one a squared. So if I come up here, and I look at this one, this negative x, it's assumed or understood that there's only one of them. It's not two x's, there's only one. So we don't have to write the 1 in front of the x, we just know that there's only one, okay? All right, so let's take a look at some examples. So sorry, I made a typo there. If a term is written without a sign, it's understood that the number is positive. Okay, so like this one up here, 9 squared, it's understood that that's a positive number. It's not negative. All right, so we're going to use that example from up above right here again. Here it is. Okay, and there's our terms. So if we were to break it apart, it would look like each term could be in its own box. Okay, and the number associated with it would be a positive 3, even though we don't have a positive symbol. That's understood. A negative 1 and a negative 4. Okay, and then down here, the variable with the term is an x squared, x, and there's no variable for this one. Okay, so we're breaking it apart to look at it and kind of study how these algebraic expressions are put together. So it's not necessary for a term to contain a variable, like this one up here has no letter next to it. So if it does not contain a variable, we call that a constant term, meaning it never changes. So here's an example. If I said 1x, 2x, 3x, if x is a number like 2, then I would end up with 2, 4, 6 as my answer, okay? But here, 4 is always going to be 4. It'll never grow, okay? All right, let's take a look at the next one. So constant terms can be combined by algebraic addition, and we've been practicing that. Like when we add 4 plus 6, or let's say it was 4 minus 6, we could combine or simplify those two. So here's an algebraic expression, 3x plus 3 minus 1. And we just look at it and we go, okay, the 3x doesn't have anything to add to it because we can only add like terms. But the 3 minus 1 becomes plus 2. Okay, so we end up with 3x plus 2, and you'll see some examples. Terms can also be combined by algebraic addition if they are like terms. Like terms mean they have identical variable parts. okay? So if I look at this, each term could have a constant or a number, and then any combination of variables. But the minute you see the separation with a plus or a minus, you know you're going to a new term, okay? So when I look at this, the way I read it is minus 3xy squared combined with 1xy squared. So I have minus 3 of them, and I have 1 of them, okay? And we know from practice that whichever number is bigger and has whatever that sign is what our answer is, okay? So we combine them by algebraically adding the signed number part of the terms, okay? So a minus 3xy squared combined with 1 positive 1 gives me a negative 2xy squared, okay? This is no different than over here. If I said negative 3 plus 1, you'd tell me, oh, that's negative 2. If I said negative 3a plus 1a, I would get a negative 2a. It's kind of like on a number line. If I went back 3 and up 1, I'd land at negative 2. It's no different than here. We just are using variables to represent numbers that we don't know, okay? So let's go down here. We're going to use the commutative and associative properties to collect the terms, okay? So first off, let's just look at it closely and break it up into terms so we can separate it. Every time you see a symbol, okay, we can divide it into different terms, all right? So the given is that it's 4x plus y plus x minus y. The commutative property says that we can switch these things around, okay? And because this little slash symbol is like combined with, remember algebraic addition, we would put like a plus, negative y plus, okay, so we can do that. So we just rearrange them and we group them up. 4x plus x, we move the x up here to the front, and then a y minus y. We're just sticking them next to each other. Associative property says we can group them with parentheses. So we have 4x plus a y minus y, which if we were to add them up, that would be 5 x's altogether, and no y's because y minus y is 0. So our answer is 5x. Okay. Here comes another one. Okay, so this looks scary, but it's not. We just need to group them up by which ones match. It's kind of a matching game, okay? So the automatic thing I think of is that I always want to pull things with exponents to the front of the line, okay? So if it has an exponent, or if it has more than one variable, like an x and a y in one term, those tend to go first in equations. It's just kind of the mathematical thing to do. So it's given right here. And then our commutative property says we're going to pull these squared numbers up to the front of the line. Okay, so we go 2x squared plus x squared. And then we go to the next thing. This has no squared. We go 5x minus an x plus a 4 minus 1. Okay, just rearranging them. As long as their symbol travels with them, you can totally do that. And then the associative property tells us to lump them together with parentheses. So I find the ones that are similar, and those have x squares, those are just x's, and those have nothing. And then I start adding them. 2x squared, 2 of them, plus 1 of them is 3. I have 5 minus 1 of them gives me a 4x, and a 4 minus 1 leaves me with 3. Okay. All right, so last example. I can divide the terms if I'm having a hard time seeing them, but just remember the symbol travels with the term. So that's given. And so we start grouping them, okay? I pull the squared numbers to the front. So I'm looking, I see 2 of them. So I go 4x squared minus 3x squared. Then comes the x's, plus 2x minus an x plus 3y plus y, okay? And then I start lumping them together with parentheses, and I keep them collected, okay? And then I look at it and I say, okay, I have 4 of these minus 3 of these gives me 1 left over, and I don't need to write the 1, it's given. And then I have 2 x's minus an x, that gives me 1 left over. And I have 3 y's plus 1 more gives me 4y, okay? All right, so I'm gonna hit pause, and I'm gonna post the practice set on a separate video.